Back here in data science, we're going to continue our attempt to define data science by looking at something that's really well known in the field, the data science Venn diagram. Now, if you want to, you can think of this in terms of what are the ingredients of data science. Well, we're going to first say thanks to Drew Conway, the guy who came up with this. And if you want to see the original article, you can go to this address. But what Drew said is that data science is made of three things, and we can put them as overlapping circles because it's the intersection that's important. Here on the top left is coding or computer programming, or as he calls it, hacking. On the top right is stats, or stats in mathematics, or quantitative abilities in general. And on the bottom is domain expertise, or intimate familiarity with a particular field of practice, business or health or education or something like that. And the intersection here in the middle, that is data science. So it's the combination of coding and statistics in math and domain knowledge. Now let's say a little more about coding. The reason coding is important is because it helps you gather and prepare the data, because a lot of the data comes from novel sources and is not necessarily ready for you to gather, and it can be in very unusual formats. And so coding is important because it can require some real creativity to get the data from these sources to put it into your analysis. Now, a few kinds of coding that are important. For instance, there's statistical coding. A couple of major languages in this are R and Python, two open source free programming languages. R specifically for data, Python's general purpose, but well adapted to data. The ability to work with databases is important too. The most common language there is SQL, usually pronounced SQL, which stands for Structured Query Language, because that's where the data is. Also, there's the command line interface, or if you're on a Mac, people just call it the terminal. The most common language there is Bash, which actually stands for Born Again Shell. And then searching is important, and regex, or regular expressions. While there's not a huge amount to learn there, it's a small little field. It's sort of like super powered wildcard searching that makes it possible for you to both find the data and reformat it in ways that are going to be helpful for your analysis. Now let's say a few things about the math. You're going to need things like a little bit of probability, some algebra, of course, regression, very common statistical procedure. Those things are important. And the reason you need the math is because that's going to help you choose the appropriate procedures to answer the question with the data that you have. And probably even more importantly, it's going to help you diagnose problems when things don't go as expected. And given that you're trying to do new things with new data in new ways, you're probably going to come across problems. And so the ability to understand the mechanics of what's going on is going to give you a big advantage. And the third element of the data science Venn diagram is some sort of domain expertise. Think of it as expertise in the field that you're in. Business settings are common. You need to know about the goals of that field, the methods that are used, the constraints that people come across. And it's important because whatever your results are, you need to be able to implement them well. Data science is very practical and it's designed to accomplish something. And your familiarity with a particular field of practice is going to make it that much easier and more impactful when you implement the results of your analysis. Now let's go back to our Venn diagram here just for a moment. Because this is a Venn, we also have these intersections of two circles at a time. At the top is machine learning. At the bottom right is traditional research. And on the bottom left is what Drew Conway called the danger zone. Let me talk about each of these. First off, machine learning, or ML. Now you think about machine learning, and the idea here is that it represents coding or statistical programming and mathematics without any real domain expertise. Sometimes these are referred to as black box models. They kind of throw data in and you don't even necessarily have to know what it means or what language it's in, and it'll just kind of crunch through it all and it'll give you some regularities. That can be very helpful, but machine learning is considered slightly different from data science because it doesn't involve the particular applications in a specific domain. Also, there's traditional research. This is where you have math or statistics and you have domain knowledge, often very intensive domain knowledge, but without the coding or programming. Now, you can get away with that because the data that you use in traditional research is highly structured. It comes in rows and columns, it's typically complete, and is typically ready for analysis. Doesn't mean your life is easy, because now you have to expend an enormous amount of effort in the method in designing the project and in the interpretation of the data. So still very heavy intellectual cognitive work, but it comes in a different place. And then finally, there's what Conway called the danger zone. And that's the intersection of coding and domain knowledge, but without math or statistics. Now, he says it's unlikely to happen, and that's probably true. On the other hand, I can think of some common examples, what are called word counts, where you take a large document or a series of documents and you count how often each word appears in there. That can actually tell you some important things. And also drawing maps and showing how things change across place and maybe across time. You don't necessarily have to have the math, but it can be very insightful and helpful. So let's think about a couple of backgrounds where people come from here. First is coding. You can have people who are coders who can do math, stats, and business. So you get the three things, and this is probably the most common. Most of the people come from a programming background. On the other hand, there's also stats or statistics, and you can get statisticians who can code and who also can do business. That's less common, but it does happen. And finally, there's people who come into data science from a particular domain. These are, for instance, business people who can code and do numbers, and they're the least common. But all of these are important to data science. And so, in sum, here's what we can take away. First, several fields make up data science. Second, diverse skills and backgrounds are important and they're needed in data science. And third, there are many roles involved because there's a lot of different things that need to happen. We'll say more about that in our next movie.